So welcome back, and this is going to be our very last lesson on this topic before we start our next topic, which is trigonometry. Let's dive straight in and let's have a look. So we've got this question over here where we've got these two functions, and it asks us to determine the maximum distance that they are apart. Okay, sorry, the minimum distance that they are apart, the minimum length of this line over here. Now the important thing here is that because this line is a vertical line, the x values of these 2 points, of point A and point B, will be the same. Point B will have if it's got an x value of negative of x, then its y value will be minus 2x minus 4. That's because it lies on that line. A will have an x value of x, where that x is exactly the same, and a y value of x squared minus 4x plus 8. Now, the length of this line will be the bigger y value minus the smaller y value. All right, and that's worth just sort of remembering always. A vertical line, just the bigger y value minus the smaller y value. Notice that this smaller y value is actually negative, but when we subtract a negative, we end up adding. So the length of the line AB is actually just going to be, it's going to be x squared minus 4x plus 8 minus negative 2x minus 4. And that comes to, AB comes to x squared minus 4x plus 2x, that's minus 2x, plus 8 plus 4, so that's plus 12. Now, when we just look at that, it's impossible to tell really anything about it. But if we can write it in this form here, in a sort of completed square form, and remember that when we square out, we're going to get the x squared. Whatever we put here is going to double, right? And so we need to put a minus 1 here. When we square this out, we still have the plus 12. When we square this out, we get x squared, we get a negative 2x, and then we get a plus 1. Now that plus 1 was not there, so we need to subtract 1. Right. So what that actually means is that AB is actually, and I'm going to write it over here, and I apologize that I'm sort of jumping up and down here, but I'm going to write it over here. AB is actually x minus 1 all squared plus 11. Now, that there is a very useful form, because we know that when we square something, it is always at least 0. It can't be negative. And that means that this piece here is always at least 0. And that means that AB is bigger than or equal to 11. All right? The smallest value AB can have is 11. All right? So AB minimum value is 11. When x equals 1. Because when x equals 1, we won't be adding anything onto the 11, because that bracket will be 0. Okay, right. Let's just have a look at a little picture of what's happening here now for the next part, because then it says, determine the value of p for which f of x plus p equals g of x has exactly one root. Now this here is going to be a vertical shift. At the moment, the graphs do not intersect. The parabola does not hit the straight line graph. But if we were to drop it down, all right, then they would touch at one point. And if we dropped it down enough, they would actually intersect. So the value is, for p, we need p to be minus 11, because that is the length of this line. All right, and if we drop it down, then point A will be on top of point B. Let's just have a look at a picture of this. Okay, so there we've got the picture as it kind of was. Now notice, obviously we can move that graph up, or we can move it down. The moment we're moving it down, so there's our red graph, and you can see P is, at the moment, P is minus 7, right? Minus 8, minus 8.5, minus 9, minus 9.5, minus 10, minus 10.5, minus 11. At that point, the graphs just touch one another. If we make P smaller than minus 11, then we get 2 distinct points of intersection. Okay, we hope that these sort of visuals are helping make sense. I'm just putting it back to where they were to start off with. Okay. Right, so here we've got a picture of what's actually going on there. And there's the red graph in its original position. That's the original function f. And there's g. And notice that we can move the red graph down by adding a negative number at the back. And we'll notice that when it gets to exactly minus 11, the graphs just touch at one point. If we go more than minus 11, in other words, we drop it more than minus 11, then they actually cut at two different points. Minus 11 is that value that we've just found. Okay. Right, now the last thing we want to just look at, which we should have included in the notes, but it's basically a really important skill, and it's something that we've just seen right now. All right. First is just that when we have a parabola in the form, for example, x squared plus 4x minus 3, we aren't really able to tell much about that parabola. But if we could write it into this form, then with some number over here, then we can actually see what its turning point will be, because we can see that it's just the parabola x squared shifted. Right, so let's take a look at this. Before we do this, just a quick reminder that when we square, for example, a plus b, right, if we write it out, two brackets next to each other, and we square it properly, we get a squared, we get b squared, but we also get 2ab. And that 2ab is absolutely vital. That 2ab is the product of those two things and then doubled. And the reason it's doubled is because we get them from the outer pair and the inner pair. Right, so now what we want to ask ourselves is, if I want to square this out and I want to get 4x, I must not put 4 here, right? Because whatever I put here is going to multiply with the x and then double. So in fact, to compensate for that doubling, I need to halve it. So instead of x plus 4, I'm going to put x plus 2. All right, now if we square this out, okay, there's the minus 3 which we had before. If we square this out, we're going to get a 4, a positive 4, which we didn't have before, so I need to subtract a 4. If we calculate this whole thing, we get exactly the same value as on the previous line. And so in fact, this is just y equals x plus 2 all squared minus 7. But this, if we think about it, this is just y equals x squared. All right, now we know where y equals x squared turns. Y equals x squared turns on the origin, doesn't it? It turns there at 0, 0. But how has it moved if we've added 2 to every x and subtracted 7 at the end? This is y equals x squared. This over here is y equals x squared moved 2 left and 7 down. 2 left and 7 down. And so the turning point of this, if we move the point 0, 0, 2 to the left and 7 down, then the turning point will be negative 2, negative 7. And this is called the turning point form for a parabola. Okay, we're going to do one more, all right, because sometimes we've got a number in the front. For example, suppose we had something like y equals negative 2x squared plus 12x minus 8. Right, the negative 2 is a bit of a problem, but what we're going to do is we're going to factor it out. We can't divide it out because this is an expression for y. Whatever we write on this line has to equal what we had on the line before. Inside here, we're going to get x squared. We're going to get minus 6x, and we're going to get plus 4. Right? Now, inside the square brackets, we are going to try and complete the square again. So we're going to work out, what do we need? And it must be x minus what? It must be x minus 3 all squared. If we square this out, we get a plus 9 that we didn't have, so we must have a minus 9. We've still got the plus 4. Okay, now, last line, we're going to multiply this minus 2 back in. So we get minus 2 x minus 3 all squared. We had a minus 9 plus a 4, that's minus 5 times negative 2, that's plus 10. Right, and now what we've got is that this is just a negative parabola, a sad parabola, right, shifted. It's actually the graph negative 2x squared, which is just a bit tighter, sad and tighter. It shifted 3 to the right and 10 up. So this one has a turning point at 310. Okay, right. That brings us to the end of our study of functions. In the next lesson, exciting times, we will be tackling trigonometry. Look forward to seeing you then. Have a great day.